African elephant. African elephants are members of the genus Loxodonta comprising 2 living elephant species. The African bush elephant L. africana and the smaller African forest elephant L. cyclotis. Both are social herbivores with gray skin, but differ in the size and color of their tusks and in the shape and size of their ears and skulls. Both species are considered at heavy risk of extinction. On the IUCN Red List, as of 2021, the bush elephant is considered endangered and the forest elephant is considered critically endangered. They are threatened by habitat loss and fragmentation, and poaching for the legal ivory trade is a threat in several range countries as well. Loxodonta is one of 2 extant genera of the family Elephantidae. The name refers to the lozenge-shaped enamel of their molar teeth. Fossil remains of Loxodonta species have been excavated in Africa, dating to the Middle Pliocene. The first scientific description of the African elephant was written in 1797 by Johann Friedrich Blumenbach, who proposed the scientific name Elephas africanus. Loxodonti was proposed as a generic name for the African elephant by Frederick Cuvier in 1825. This name refers to the lozenge-shaped enamel of the molar teeth, which differs significantly from the rounded shape of the Asian elephant's molar enamel. An anonymous author used the Latinized spelling Loxodonta in 1827. Anonymous was recognized as authority by the International Code of Zoological Nomenclature in 1999. Elephas Loxodonta cyclotis was proposed by Paul Matchie in 1900, who described 3 African elephant zoological specimens from Cameroon whose skulls differed in sh. Ape from elephant skulls collected elsewhere in Africa. In 1936, Glover Muriel Allen considered this elephant to be a distinct species and called it forest elephant. Later authors considered it to be a subspecies. Morphological and genetic analyses have since provided evidence for species-level differences between the African bush elephant and the African forest elephant. In 1907, Richard Lydecker proposed 6 African elephant subspecies based on the different sizes and shapes of their ears. They are all considered synonymous with the African bush elephant. A third species, the West African elephant, has also been proposed, but it needs confirmation. It is thought that this lineage has been isolated from the others for 2.4 million years. Extinct African elephants. Between the late 18th and 21st centuries, the following extinct African elephants were described on the basis of fossil remains. The North African elephant Loxodonta africana farahensis is an extinct subspecies of the African bush elephant Loxodonta africana, or possibly a separate elephant species that existed in North Africa, north of the Sahara, until it died out in Roman times. Loxodonta atlantica is an extinct African species of elephant in the genus Loxodonta, which includes living African elephants. It was larger than modern African elephants, with more progressive dentition. It includes Pleistocene fossils from Ternafine, Algeria, Middle Pleistocene fossils from Malandsfontein, South Africa, and Late Pliocene fossils from the Omo River, Ethiopia. Loxodonta exoptata is an extinct species of elephant in the genus Loxodonta, from Africa. A 2009 study suggested that Loxodonta exoptata gave rise to L. atlantica, which gave rise to L.africana. The molars of L. exoptata are distinguished from later loxodonts by the lower plate number and their specialized enamel loops. Fossil remains of L. exoptata have been found at Pliocene sites in eastern Africa, including Hatter, Latoli, and Cubiphora. Loxodonta odorata is an extinct species of elephant in the genus Loxodonta, that of the African elephants. Fossils of Loxodonta odorata have only been found in Africa, where they developed in the Pliocene. L. odorata was presumed to be the genetic antecedent of the 2 modern African elephant species. However, an analysis in 2009 suggested that L. africana evolved from L. atlantica. The same study concluded that Loxodonta odorata was morphologically indistinguishable from Mammuthus subplanifrons, and that these constituted the same species, probably within the mammoth lineage. However, other authors have continued to consider L. odorata a valid species of Loxodonta, with some considering it an early morph of Loxodonta exoptata. Analysis of nuclear DNA sequences indicates that the genetic divergence between African bush and forest elephants dates to 0.6 to 5.6 million years ago. The divergence between the Asian elephant and the woolly mammoths is estimated to 0.5 to 5.4 million years ago, which strongly supports their status as distinct species. African elephants have gray folded skin up to 30 millimeters (1.2 in thick. That is covered with sparse, bristled dark brown to black hair. Short tactile hair grows on the trunk, which has two finger-like processes at the tip, whereas Asian elephants only have one. Their large ears help to reduce body heat. Flapping them creates air currents and exposes the ear's inner sides, where large blood vessels increase heat loss during hot weather. The trunk is a prehensile elongation of its upper lip and nose. This highly sensitive organ is innervated primarily by the trigeminal nerve and thought to be manipulated by about 40,000 to 60,000 muscles. Because of this muscular structure, the trunk is so strong that elephants can use it for lifting about 3% of their own body weight. They use it for smelling, touching, feeding, drinking, dusting, producing sounds, loading, defending, and attacking. Elephants sometimes swim underwater and use their trunks as snorkels. Elephants are the animals with the lowest sleep times. Especially African elephants, their average sleep was found to be only 2 hours in 24-hour cycles. While feeding, the African elephant uses its trunk to pluck leaves and its tusk to tear at branches, which can cause enormous damage to foliage. Fermentation of the food takes place in the hindgut, thus enabling large food intakes. The large size and hindgut of the African elephant also allows for digestion of various plant parts, including fibrous stems, bark, and roots. African elephants are highly intelligent. They have a very large and highly convoluted neocortex, a trait they share with humans, apes, and some dolphin species. They are amongst the world's most intelligent species, with a mass of just over 5 kilograms 11 pounds. The elephant brain is larger than that of any other terrestrial animal. The elephant's brain is similar to a human brain in terms of structure and complexity. The elephant's cortex has as many neurons as that of a human brain, suggesting convergent evolution.
Thanks for watching.